Okay guys, welcome back to another A-level free tuition lesson. Today we're going to be covering trigonometric equations and also doing the cast diagram. So the cast diagram tends to be quite a popular method of solving it. There are other ways as well, but just as a brief introduction, let's say I wanted you to solve the equation sine x equals 0.5, right? Now most of you would probably tell me that all you'd have to do is do x is equal to inverse sine of 0.5, and then you'd get your answer, right? So then you just go straight to your calculator, and so let me just bring up my calculator quickly. And again, you just do inverse sine 0.5, and you'll be done. 30 degrees, easy peasy, right? Now the thing is, if we actually look at the sine graph, right? So if we draw the graph down the middle, starts off at 0 and it goes up and down, and so on, right? And even on the other side, it repeats as well. Now, if we're looking at the values of a half, so this is +1, this is -1, the values of a half are going to be here. Now, if you look, it actually crosses at multiple points, right? Where the y-axis equals a half. So the problem is that although this is a correct solution, it's only one solution, so one solution of an infinite number of solutions. Okay, so we could also have a negative answer as well, and we could have an infinite number of positive answers and an infinite number of negative answers, because these graphs go on forever. The same is true for the cosine graph and the tan graph as well. So basically, we can't actually tell where, or in a sense, which answer is correct, so to speak. So what you'll find is in A-level, what they decide to do is they decide to give you certain boundaries and limits for what you're going to do. So what they might say is that solve or find all solutions, so solve sine x equals 0.5 in the region of, and generally speaking, it would be like 0, x to 360. Okay. So what you'd do is, once again, we have that x equals 30 degrees. But then what can we do with it? Well, we use something called the cast diagram to find the other solutions. Okay. The cast diagram is a fairly simple, draw a little 2x2 grid, and then you label it C, A, S, and T. And what this allows you to do is work out all of the other values for sine. So again, this can be kind of tricky, but the way I like to teach it and the way that seems to work well for other students is to kind of go through a bunch of questions and slowly but surely add more and more information. So while there are questions that are this simple, most questions actually are a bit more complicated than just doing this. You can have negative signs, you can have negative angles, and you can also have extra things before the x and after the x too. But for this one, what would you do? Well, what you'd first do is you draw 30 degrees, which is our answer, onto our graph. Now we always start from clockwise and we move anti-clockwise. So basically this is 0 degrees, this is 90 degrees, this is 180 degrees, this is 270 degrees, and then back round to 360 degrees. Okay, so our 30 degrees would look something similar to this. And what we need to ask ourselves now is whether or not our value is positive or not. Well, this is a positive value, so we need to find the other place where sine x is a positive number. And sine x is positive in the A quadrant, which stands for all, and the S quadrant, which stands for sine. So we draw 30 degrees there again. And you're always drawing this from the x-axis, not the y-axis. So again, just so you know, all of these values here, all of these letters, stand for different trig functions. So cosine, the A stands for all, which means tan, sine, and cos are all positive in that first quadrant. sine for the s, and tangent for the t. Okay, and the idea is that in each of these quadrants, a certain number of trig functions are positive. So in the C quadrant, only cosine is positive. So if we had cos x equals 0.5, we'd be drawing another line in cos. If it was tan x, then we're drawing the tan sine. And that's it. So now the question is, what is this actual angle, given that we always measure angles anti-clockwise? Well, it doesn't get to 180 degrees. It's 30 degrees less than that. So it would be 150 degrees. So our two answers are 30 and 150 degrees. Okay. Now, because we're only going up to 360, I'm not going to go back around to the next one, because if I were to go all the way around, that would be 360 plus 30 degrees, 390 degrees, which is outside of our range, so I don't include it. Okay. So hopefully that was okay as an introduction. I know it's quite overwhelming, but I believe that through practice and a good explanation, anyone can learn to use the cast diagram, and it becomes very, very useful indeed. So again, that was just a basic example. Let's go on to these questions. So here we go, solve for, and then they give us a range. So that's a good first thing to look at. And now it says cos 2x plus 15 equals 0.3. So the first thing you might notice is that we have inside the bracket 2x plus 15. And we're solving for x. Now, the problem with this is it's actually going to change the range of values we can accept, okay? Because we're going to end up halving what this is, so we can actually go twice around. So what we need to do is, to both sides of this, we multiply it by 2 and add 15. So 0 times 2 is 0, plus 15 is 15, less than or equal to 2x plus 15. 180 times 2 gives me 360, plus 15 gives me 375. So for the initial part, we're just going to work out what the overall values are for this whole thing. Then we're going to subtract 15 and divide them by 2 in order to work out what x would be. So 2x plus 15 is equal to the inverse cos of 0.3, which if we work out on our calculator, (72.5 degrees), and it says give your answer to one decimal place, so 72.5. Okay. Now we go straight to the cast diagram. Okay. We're going to ignore the 2x plus 15 for now and do that right at the end. Okay. Now we're going to find all of our values in the range of 15 to 375. So again, our first value, and again we can label this cast. So again, the angle that we get from working out on our calculator, we always put in the all column. That's 72.5. Now our answer is indeed positive, right? 0.3 is positive. The angle's positive, so we're going to go anti-clockwise, and since we're doing cos, we're going to go into the C section, which will be down here. And again, always draw your angle from the x-axis. So we're looking for this value that's all the way around the back, which is going to be 360 minus 72.5. Which gives us 287.5 degrees. Now if I go around again and look at this angle, I can see straight away that I'm going to get a number that's outside my range. What I would get is 432.5. Now if I look at my range, the upper limit is 375, so I don't include this. And obviously all future values will also be outside the range. I also don't go the other way into the negatives because my lowest value is a positive number. So these are my two values for this. So with x equals, what we need to do is subtract 15 from these numbers and divide them by 2. So we have 72.5 minus 15 and then divided by 2 gives me an answer of 28.75, so 28.8 degrees. And do the same for the other one. We have 287.5 minus 15 divided by 2 gives me an answer of 136.3 degrees to 1 decimal place. Yeah. Hopefully that wasn't too bad. So far. I'm going to keep going. Perfect. So again, solve for between 0 and 180, the equation this. So again, we have 3 theta minus 15. So on both sides of our equation, we need to times them by 3 and minus 15. 0 times 3 is 0, minus 15 is minus 15. And then 180 times by 3 is 540. Minus 15 gives us 525. So in this one, we're more than likely going to go round the cast diagram multiple times. So it might get a bit messy, but hopefully you can see the idea. So cool. So that equals an answer of 44.4 degrees. And it says 2 decimal places, so 44.43 degrees. So again, let's go and look at the cast diagram. Cool. So again, in the or section, we're going to write 44.3 degrees. And since we used the sine symbol, and these are all positive, we're going to draw the other line in the S section. Okay. So again, our next angle will be from here all the way to the line, which will be 180 minus 44.3. 0.43, I keep saying 0.3. 135.57. And again, since we haven't reached the upper limit of 360, I'm going to go around one more time. So go all the way around to here. That would be 360 plus 44.43, which gives me 404.43. And we're still not at the edge, so we can go all the way around back into the S section again. Which would be, so in this case, this is 360, add another 180 would give me 540. So it'd be 540 minus 44.43 gives me 495.57, which is still in the range. And we can't go again. Now you may be wondering, I have a negative in my range, so I could actually go anti-clockwise. But as you can see, if I go anti-clockwise, so if I look at an angle all the way from here round to here, that's going to be too big. It's going to be a lot bigger than minus 15. It'll be minus 180 minus 44.43, which would be a lot bigger than 15. So once again, if we want to work out what theta is, we need to add 15 to all these numbers and divide by 3. So 44.43, add 15, whoops, and then divided by 3. 19.81, and again to 2 decimal places. 50.19. So again, the reason why I'm doing it in this particular way, and there are other ways to do it, is that a lot of the times in this question, students, again, know how to do the work, they understand it, but they end up missing a value or two. And the problem is you drop entire marks from just missing one value. So when you do it this way, it kind of guarantees you get every value in the range. Technically speaking, you can do it in one step, but I find it tends to lead to errors among students. You should only really do it if you're hyper comfortable. If you look at our range again, 0 to 180, we've got 4 values. That's pretty impressive. It seems like we got them all. Okay? So just be really careful when it comes to that. And again, in a 5-mark question, losing a mark is pretty devastating. It's 20% of the grade gone. I'll leave that up there for a second. Okay. So here we have our first negative, okay? And I'll show you exactly what happens with that. So, first off, if we're doing theta plus 30, then our range now becomes minus 150 degrees. Also, please pay attention to the equal sign as well. So sometimes the value is exactly 180 or minus 180. In this case, minus 180 is accepted, 180 is not. You will lose a mark for every additional value that is not on the mark scheme, so please be careful. So theta plus 30 is just equal to the inverse tan of minus 2.5, which equals, again, minus 68, and this is one decimal place, so minus 68.2. Perfection. Okay. So now, let's draw this. It's a negative number, so we're actually going to go clockwise instead of anti-clockwise, so this is where that will be. And the other section, so keep in mind, our value is negative. So you remember how in the previous few questions I asked, well, where else is it positive? In this case, I'm looking, where else would this value for tan be negative? Well, it's going to be in the sine column, because A and tan are both going to be positive. And that's going to give me 68.2. So my other value, or one of my other values, is going to be that angle there. So again, there is sometimes confusion of whether or not we'd still measure it clockwise. If you measure it clockwise, you'll get a negative answer. So you do 180 plus 68.2 and make it negative, which in this case would be outside of our region, right? Because 68 plus 180 would be approximately 248.2, which is outside this range. And outside this one too. So we don't need to worry about that. We're looking at the inside one. 180 minus 68.2. And again, we're not doing minus 68.2 or anything like that. That would be the negative answer. So we get 111.8 degrees. Now I ask myself, if I go around again, either way, will I get an answer? Well, if I go around this way, so I read all the way around until this line, I would have 360 minus 68.2, which again is a valid answer, right? So 360 minus 68.2, that is a valid answer, but it's outside our range. So yes, you would go round to the C, but it's outside our range, so we don't need to do it. And if I go around again, obviously that's going to be outside our range. So in short, the only two answers we have are these two. Now that's not our final answer. To work out what theta is, we need to subtract 30 degrees from both of them. So we have that'd just be minus 98.2. That's not too bad. And that would be 81.8 degrees. And that'd be it. Not too shabby. So the cast diagram is extremely powerful in working out the answers. The other way to do it is to memorize a bunch of rules of like adding and subtracting from 180 or from 360. Some people like that. I think it's a bit too much memorization. In general, if there's a way you can do something without memorizing something, that's the best way to do it. And yes, I recognize that, you have to learn like times tables and stuff, but So, in a situation like this where we have that, what do? Well, it's quite simple really. We can solve it just like a normal equation, right? So, generally speaking, I just want cos by itself. I'm going to divide both sides by 5. And that is what I'm going to solve. Okay? The only reason why we don't do that for the bits inside is you can't really get rid of the stuff inside, right? Without inverse cosing first, which is where we have the multiple solutions bit, okay? So we have to get rid of the number in front first. But for this one, for the bit in the middle, we have to inverse cos first, which means we need to change our boundaries and all that stuff. So, x minus 40. So that makes our boundary minus 40, x minus 40, and 320. Okay, so x minus 40 would equal the inverse cos of 0.4, which is 66.4, because again, actually no, it's 2 decimal places, my bad. 66.42 then. Too bad. Once again, we're going to head over to the cast diagram. So it's relatively straight. So this is in the all section as always. And we're looking at cos here, so our other value where it's positive is going to be here. So that number there would be 360 minus 66.42, which is 293.58. Now we have to ask ourselves, well, what's our range? Well, we go up to 320, so let's see if we can go again. Well, if I go again, I get 360 plus 66. That's not going to be in the range. So we're done. So now with x, all we need to do is have all of the plus 40s. So just add 40 to all of these. So 106.42 degrees and 333.58 degrees. Nice and easy, I think. So hopefully that's all okay with that part. Okay. So this question, once again, we do something very, very similar to what we had before. However, we have to be very careful. We're going to square root both sides. So now we have tan x equals plus minus root 3. Okay, so we have to do the cast diagram twice. Okay, so what we're going to do here is we have tan x equals positive root 3 and tan x all the way over here. We're going to get a bunch of different answers, then we have to put them all together at the end, okay? So it is still one equation we're solving, it's just that we have an option for plus and an option for minus. So, x here equals, so 60 degrees, I probably should have just known that off the top of my head, didn't think. And our range is 0 to 360, so let's go. Again, when they give you these options where it's 2, like a plus and a minus, generally speaking, they don't make you do anything else, because otherwise it's a bit too much work. So 60. And since this is a positive square root 3, the other value would be here. So that would be 180 plus 60, which is 240 degrees. And if I go again, it would be 360 plus 60, which is 420, which is bigger than 360, so we're done. Those are our two values. Now with minus root 3, we get minus 60. So you can probably guess what our answers are going to be, but we don't need to because we're very intelligent. Sorry. So one of the other answers is going to be negative 240, but that's outside of our range. So again, we're going negative 60, that's here. Because again, oh god, remember, if we go clockwise, it's a negative angle. So since we have negative 60, to draw negative 60, we go clockwise. Okay. The other place where tan is negative is in the sine section. Now if I read this anti-clockwise, I get a positive number. If I read it anti-clockwise, I get a negative number. Now if you look at our boundaries, there are no negative answers because the smallest number we can have is 0. So we have 180 minus 60, which is 120 degrees. Okay. Now if I go round again the positive way, round to here, I have another value. It's 360 minus 60, which is 300 degrees. So whenever you draw like a line on this graph, think about going clockwise and anti-clockwise. Now if you can see by going clockwise you're going to get a negative and you're not looking for negatives, then you don't have to draw it, but still think about it in your head. Okay? Because I know for a fact, every time there's a question like this, this answer here is missed. Because people don't realise that although you wrote a negative angle, you can get a positive angle going the opposite way. Most students forget that. So please, please, please make sure that you're being very, very careful. Okay? Anytime you draw a line, you can get two answers, a negative angle and a positive angle. So just keep that in mind. And then of course you can go around again to get more answers. But the idea is that anytime you draw a line, there's immediately two answers to get. So the solution for the whole thing is going to be 4 values: 60, 240, 120, 300. Okay? So again, just be very, very careful with that. Sometimes there's also a part A, where sometimes there's a part A value. Okay? And this is where part where you have to manipulate trig equations. Now manipulating trigonometric equations is extremely common in A levels. Okay? A lot of A2 content focuses on manipulating trig equations as well, for integration, differentiation, solving trig expressions, just rewriting them in different forms, etc. So we have to show that this can be written as this. Now, what I like to do in can be written in the form equations is I like to compare the two equations. Okay? In this first equation, I have a sine squared. In this one, I don't have a sine squared. So I need to get rid of sine squared. The only way I know of doing that is by using the expression sine squared plus cos squared equals 1. So if I want to just replace sine squared, I get sine squared equals 1 minus cos squared. So let's sub that in, shall we? And again, we're going to keep looking back at this to see if we're getting close to the answer. Well, now if I look at the answer, I've gotten rid of the sine squared, and I know I can see I'm going to get 2 cos squared, which is in the answer. And I have the 7 cos x. Plus 3 can come from plus 5 minus 2. So we're on the right tracks. So I do apologise for my voice. Basically, I'm recovering from a flu. And although I feel completely fine, unfortunately my throat gets very dry very quickly. And it makes talking very painful. And if we move this over to the other side, this becomes positive 2 cos squared x. There's nothing that affects the 7 cos x. And then we have 5 minus 2, which is 3. Which, if we have a look, is our answer here. 3 marks, all done. You get a mark for the substitution, a mark for expanding the brackets, and a mark for rearranging. Pretty standard marking scheme there. Perfect. Now it says hence solve. Now I've told guys before, as part of our students before, that whenever you see hence in a question, what it means is always use previous part. So you'll find this in maths, you'll find it in physics, you'll find it in chemistry, biology, everything, okay? If you see the word hence, it means using the previous part. So, immediately, without even thinking, instead of this, I'm just going to write this. Okay? So we'll write that again. And just so we don't have to keep scrolling up and down, I want to copy down the range too. So, 0 to 360. Okay? So, why have they done that? Well, if we have a look at this cos squared x and this cos x, it looks like a quadratic equation. Okay, so I'm basically solving a quadratic equation where a is the number in front of this, b and c. So we can even say it's the y equals cos x and solve it like that. If that makes it easier for you, so you can rewrite the whole thing as 2y squared plus 7y plus 3. If that makes it easier for you. But if you want to factorize this, well, we can see we're going to have a 2 cos x, obviously. In a closed bracket, open bracket, we're going to have a cos x here. Again, you can use like the full method of like AC is equal to 6, 3 times 2. B is equal to 7, so 2 numbers that times to 6 add to 7 is 6 and 1. Do it like that. So if we want 6, then we're going to have a 3 here and a 1 here. Because 2 times 3 would give us the 6. Yeah. All good. Okay, so now we have either 2 cos x plus 1 equals 0, or cos x plus 3 equals 0. So we have cos x equals negative a half, or cos x equals minus 3. So, some of you eagle-eyed people may see that this is a math error. Generally speaking, so no solutions. For those of you that didn't spot that, the reason for that is you cannot, so you can't inverse sine or inverse cos numbers that are bigger, so numbers that are bigger than the modulus of 1, right? So what I mean by that is if it's bigger than minus 1 or plus 1, you can't actually inverse cos it because they're a ratio of the opposite and hypotenuse, right? So if opposite over hypotenuse is bigger than 1, means the opposite side is bigger than the hypotenuse, which is impossible. Okay? So you can't inverse sine or cos numbers bigger than 1 or lower than minus 1. Okay? And again, the reason for that is because otherwise the adjacent / opposite side would be bigger than the hypotenuse. So really focusing on this, which, helps us out a little bit. So x is equal to the inverse cos negative a half. Again, whoops, 120 degrees, but that's nice. So this is quite an interesting situation. Normally, or in the previous questions that we've just done, when the value here is negative, our angle's negative, but in this case it's positive. So what do? Well, we're still going into the all section, but if you notice it's 120 degrees. This is 90. So it's actually going to be something like that, where this value is 120 degrees. This value here would now be 60 degrees. Okay? So, where else is cos negative? Well, it's going to be in the tan section. And if we were to go all the way around, we have this would be 60. So we'd have 180 plus 60, which is 240. And if we go around again, obviously we get a number bigger than 360, which is outside our range. So those two are only values there. In terms of the class diagram, that's basically as difficult as it gets. The key things to remember, just to kind of go over, is, so if we do a little summary now, is, let's find some space. Okay, so if we do a little summary, what, don't know what happened there, okay. Okay. Negative angles are clockwise. Positive angles are anti-clockwise. Okay. Now this both refers to drawing and reading the values. So if you ever want to read a negative value, you go clockwise. If you ever want to write a negative angle, you go clockwise as well. Okay? So reading and drawing. The next thing that I think would be important to remember is every line has positive, and I know I'm not using my contraction now, and negative angles with it. Right? Which means if I ever draw a line on that thing, I can go clockwise to it or anti-clockwise to it and get valid solutions, okay? So really important for when, I like the common place that I would say to be wary of is, so be wary of negative angle limits. So one of the questions, so keep in mind, this will come up in your Year 12 mock and in your Year 13 final exam. The part where there was a really, really tricky question where it said, find the solutions in minus 360 degrees to 0 degrees. So many students lost marks. Now, the interesting thing about this is students tend to say that this is easy, right? But if it's easy, then you wouldn't make mistakes if it gives you something like this, right? You're meant to go clockwise for all of the values. They just broke down completely. So make sure you're practicing with negative limits, positive limits, limits bigger than 360, etc. Right? So if this limit was minus 720, would you be able to do it? Let's see. Okay? It means you have to go around twice. Okay? So just be very wary of that. This, I would say, is a pretty good summary of it. Of everything you need to know. So again, if you have any questions, feel free to comment and make sure that you join in the lessons live to make sure that you kind of get help as and when you need it. Okay, but other than that, I'll let you guys get on with your evening.